The regularization is one technique to prevent overfitting. And let's see what is the regularization. So they will ask you what is the regular and the regularization L1 and L2. So regularization is a technique to prevent overfitting by adding penalties to complex models. And why we need it, as I said, that it's just sometimes the training data is working perfectly well, but where it's not working with the validation or test data set. So it's not, let's say, generalized to the whole data set. And there are two different regularization models, let's say methods. It's one L1 Lasso and rigid L2. And L1, as you can see, it's somehow adding penalty to uh, to equal the absolute value of the coefficient. So it starts creating sparse models. So most of the coefficients will be closing to maybe zero, depends on the lambda. And also the rigid one, let's say rigid or L2, it's adding equal to a square coefficient. We will see the equations here, and you can see here this is the L1. You have after, let's see, after the forward propagation, we have to calculate the, let's say, the loss function and everything, and after that we will add this lambda and the coefficient L1 and or L2. And you can see L1 and L2, it's L1, it's adding the absolute value of the weights, and this one here is squaring the absolute squaring the weights of of the the weight, let's see. And if you see here, the lambda, if lambda is zero, so there is no regularization. If it's infinity, it maximize maximum. The regularization is all coefficients is zero. So we have to this it won't let's say it won't be infinity. And maybe you will ask question if L1 it's not working, so you have to see we can add L2 with as well. This called elastic net. And how do L1 and L2 differ in effects? So by the way, I have also one video here which is explaining the L1 and L2 in a free details. Let's see with examples. You can see here with numerical example. So I'm quite sure that you will understand everything here. And the difference between L1 and L2 is that L1 is creating a sparse solution. As I said, if you see most of the, I mean, not some of the coefficient will be exactly zero. So some features will be zero, and the other one will be, let's see, the most representative will be not zero. But here it will use the most all, let's see, all coefficients, but with different, let's see, weights. And it's used for feature selection, and this one here is keep all features, and here's absolute value and here's square values. And this is let's see how to what is the difference between L1 and L2, and when to use L1 versus L2. So you need, if you would like to use a feature, this is, let's say, to offer it's used for overfitting. And now when to use L1 and L2. L1 if you need to select features, if you have a working high dimensional data and you would like to reduce this dimensionality to work with your resource, let's say CPU, GPU, and sometimes many features are irrelevant, so it will be removed. So this code, you will have finally a sparse model. But for this one here, if you all the features are potentially relevant, so features are correlated, and you need stable solutions. And so sometimes the L2, the L1 is sensitive, and the L2 is working okay. And for instance here, a quick decision. Do you need to eliminate features? Use L1. Are features highly correlated? L2. Want to keep all features? Then L2. And let's see. And some here you ask about choosing between one and two. So mention that you can use, you can also combine them uh, using elastic net. As I said in the beginning, it's elastic net. If, for instance, they will ask why if not L1 it's not working, or maybe L2 is not working, so we can see. I will try to combine both. And here's the summary. As you can see here, penalty type, it's absolute value. Eliminate features, sparse some features will be zero, and it's used for feature selection. And this is the formula of L1, and this is for L2. And as I said, if you have no idea about these, I have already explained this in another video. I will put it in the description, or maybe in the screen it will be pop up. So yeah, so of course if you have any question, as always, just throw it down in the comment below. Thanks for watching and see you next time.